Good morning, students. I'm Dr. Madhusudhan, working as an associate professor. Today, I'm going to give a lecture on phase diagrams. This phase diagrams topic comes under Engineering Chemistry R22. Today, discuss phase diagrams. The topics that you have in the syllabus. 1. Phases. So these topics all will come under introduction. Heterogeneous and homogeneous. Water system. Phase diagram. Water phase diagram. Topic 2. So these subtopics will come under an introduction. Water phase diagram. Lead silver phase diagram. 3. Iron carbon phase diagram. These are the 3 topics we need to discuss. So if you want to learn about phase diagram of water system or any lead acid alloys, for making of alloys is useful. All making of alloys based on the principles of phase rules only. Phase diagrams. So before discussing about water phase diagram, lead acid, iron carbon, you need to learn some important terminology about phases, heterogeneous system, homogeneous system. So under prerequisite, let me ask one small question. Prerequisites. What is difference between phase and state? Phase and state. State. Gaseous state, liquid state, physical form, which to express physical form of any matter, we use state. If it is open system, unlimited, which does not exist, when it is open system, all components are allowed to escape, chances of escape. So when state, like example, ocean, during daytime, in presence of sunlight, water vaporizes. So unlimited, you cannot measure how many states are there: water, H2O, liquid, and vaporizes, that above the surface of ocean water vaporizes. That is called vapor form, vapor state, gaseous state, air in gas form, right? Like that. So unlimited, open system. So equilibrium does not exist in that case. If it is in closed system, example, you take a water in a closed container, is completely closed system, right? Heat it, boil it. Water vaporizes. It is filled with, once it's saturated with vapor, no chance of escape, since it is closed, detached with the surroundings. So once it is saturated with vapor, you continue to keep boiling the water. Water boils, and at the surface water vaporizes. And possible phases in this closed system are 2, because after once it's saturated, this vacant space saturated with vapor H2O molecules, they collide each other, they collide with the walls and they get condensed, right? So here possible phases in a closed system: 1, liquid water; 2, vapor water. So 2 conversions are there. H2O liquid converts into H2O vapor. Liquid state. This you cannot say state. Here also 2 matter exists in 2 times, H2O. 1 vapor form, liquid form. So here instead of calling state, we need to call phase. It's a relevant word, phase. So here, if it is open system, ocean water vaporizes continuously, you cannot measure that vapor, amount of water vapor vaporized. It's a continuous unidirectional, but is forward reaction equal to backward reaction at dynamic equilibrium. At dynamic equilibrium. There equilibrium does not exist. Here equilibrium exists after some time. Once it's saturated with this vapor, no vacant space available, no chance to maintain stability inside. Molecules forced to get condensed. So when vaporization equal to vaporization, this process forward reaction is called vaporization. Backward reaction is called condensation. Right? When vaporization equal to condensation, that is called dynamic equilibrium. At dynamic equilibrium, possible states, phases, gaseous state, liquid state, liquid phase. Here we call it as phase, not state. It is limited. We can measure, physically distinct, mechanically separable. This is called phase, and they are at dynamic equilibrium. Limited, exists in closed heterogeneous system, measurable, physically distinct. Therefore, instead of state, we need to call phase, gaseous state, gaseous phase, liquid phase, like this. So, homogeneous system and heterogeneous system. If the homogeneous system, salt solution, homogeneous example. Air, outside air, unlimited, closed system. So air, different components are there, oxygen, mainly nitrogen, but uniform, same. Therefore, it is called homogeneous system. Air to salt solution, sugar solution, like this. Salt, NaCl dissolves in water, becomes homogeneous. Solution is called homogeneous. Heterogeneous, one phase is there, one phase exists, one phase. Air is one phase, salt solution one, sugar solution one phase. If heterogeneous system, closed system, two possible phases are there, If any closed system consisting of two or more than two phases, it is called heterogeneous system, right? Inside deep freeze box, possible phases are H2O, refrigerator, inside deep freeze box, possible phases, liquid water, gas, vapor, below 10 degrees centigrade, 5 degrees, 0 degrees, minus 5 degrees, minus possible phases, vapor like whitish smoke inside deep freeze box. No other word, vapor or gas form, gaseous state, liquid, and ice inside. So here possible phases are, how many are there? Three phases. Phase, you can define phase in your own words, is a homogeneous, homogeneous part of, if it consists only one, identical, then it is called homogeneous system, right? If it consists two or more than two phases in a heterogeneous closed system, it is called heterogeneous system. In heterogeneous closed system, we can define each phase. You can keeping this in mind, you can define what is phase. Phase is a homogeneous part of heterogeneous system, physically distinct, mechanically separable, known as phase. Phases, how many are there? Three phases are there. Phase, keeping one phase in mind, you can define in our own words. Homogeneous part of heterogeneous system, Why do we call it heterogeneous system? If any closed system consisting of two or more than two, this is called heterogeneous system. This is also, this can be, this equilibrium can be attained just to boil the water. Instead of loose cap covered with a insulate it, covered with complete, detached with the surroundings, completely covered with a cap, boil it, vaporizes, once saturation, once vacant space available saturated with vapor, to maintain inside stability, vapor has to be condensed. No chance, no alternative. They get condensed. When rate of condensation equal to rate of vaporization, during boiling, vapor is H2 into vapor. Once it's saturated, to maintain stability, again vapor converts into liquid. Condensation. This process is called condensation. The state at which vaporization equal to condensation, that state is called dynamic equilibrium. At dynamic equilibrium, in a closed system, how many phases are there? 2. Here, how many phases inside diffuse box? How many phases are there? 1, 2, 3. 3 phases. Ice is there, just like fog, white vapor. Another no other word, vapor or gas form, right? H2O liquid. When you open the diffuse box, ice smells. That smoke, white smokish or vapor escapes out, and equilibrium collapses. So as long as it is detached, as long as it is closed, only we can maintain dynamic equilibrium. At dynamic equilibrium, possible phases are 3. Heterogeneous system consisting of 2 or more than 2 phases. 2 or more than 2 phases. We can define phase. Homogeneous part of heterogeneous system. It is physically distinct, mechanically separable, is known as phase. You can write in our own words, phase. It is a homogeneous part of heterogeneous system. Heterogeneous system. Physically distinct, mechanically separate. Physically distinct, mechanically separable. Right? Here, how many phases are there? 2 phases. When you boil water, is there inside closed container? Possible phase 2. Here, possible phases are 2. Right? Here, how many phases are there? 3. Components. Each phase represented by only one formula. And component is called, how many components are there? 1 only. All phases composed of H2O molecules. So represented by 1. You can define in your own words component. It's a minimum number of components required. Define each composition of each phase. The smallest number of component, smallest number of chemical constant required to define composition, to express composition of each phase of system, right? Here also component is called both represented by all, whether it is gaseous form, vapor form or liquid form, composed of H2O molecules only, represented by H2O molecule formula. So minimum smallest number of chemical constant required to describe the composition of each phase. Here, how many phases are each phase? Liquid phase, vapor phase, and solid phase. Like this. You can write components also. Components. Minimum or smallest number of chemical constituents required to define, to know the composition of each phase. we need to define each phase. Depends on what, here depends on what, we need to boil the water to get an equilibrium, to equalize both conversions, vaporization and condensation. We need to supply temperature variant is there. One more variant for backward reaction, also called condensation, right? For this, so that depends. Once it's saturated, then water molecule will start exerting pressure on the wall, will start colliding each other. Then only vapor convert into liquid. That process is called condensation. Depends on pressure exerted. Second variant. So we also depend variance: temperature, pressure, and composition. Right? Variables, it can be defined as variance or variables. Minimum number of variables like temperature, pressure, components out of 3. Minimum number of chemical constant: temperature, pressure, either temperature, pressure or temperature, composition, required to describe each phase of heterogeneous system, which are at dynamic equilibrium, all phases are at heterogeneous system, and they are at dynamic equilibrium. We need to define each phase. We need to know the composition of each phase. So depends on temperature, also depends on pressure exerted by the vapor molecules, also depend on chemical constituents, composition, amount of water inside diffuse bag, amount of ice, amount of liquid. So depend on 3 variables. Minimum number of variables required. Degrees of freedom, that is called degrees of freedom. Represented by F, component represented by C, phase represented by P. Minimum number of variables: temperature, pressure, or temperature, composition. This is for alloys, to make alloys like iron, carbon, lead acid, lead silver systems, phase systems. This is just now we discussed it. Water system. And water system depends on only 2 variables: temperature, pressure. Backward reaction depend on pressure exerted inside, backward reaction. Also depend on pressure exerted. Once completely saturated, you will attain dynamic equilibrium. Then only you will attain dynamic equilibrium. That depends on pressure exerted by the vaporized molecules, vapors. So for any water, defreeze box or boiling water present in closed system, depends on only 2 variants: temperature and pressure. This is also temperature, pressure. Water system, this can be temperature and pressure. So out of 3 variables, temperature, pressure, component, minimum number of variables, either temperature, pressure, or temperature, composition or chemical constant, required to describe each phase of heterogeneous system. Each phase at dynamic equilibrium of heterogeneous system. Keeping this reaction in mind, you can define, say, heterogeneous system, and they are at dynamic equilibrium, right? So minimum number of variables required to define variables required like temperature, pressure, or temperature, composition, to describe each phase of heterogeneous system, and they are at dynamic equilibrium, right? So let me, for your clarification, I will give some example phases and components. Example, simple example, of course they are not in closed system, even it is in open system. Salt solution. So homogeneous, of course it's irrespective of homogeneous heterogeneous system. For your clarification, to know the components and number of phases, salt solution is a homogeneous, phase is called 1, but represented by two formulas, right? Solution, you can see with physical naked eye only one state, liquid state. It's composed of both NaCl and H2. Of course, they are in ionic form, that is different. We are discussing about physical state. Phase 2 will completely confined to physical state, right? Right. Salt solution, number of phases called components. How many components? NaCl dissolved in water. NaCl dissolved in water. NaCl dissolved in water. How many? And NaCl dissolved in water, represented by two formulas. 2. Right? Next, salt solution, sugar solution. Phase is called 1, only one solution, no state. Don't get confusion, irrespective of homogeneous or heterogeneous. Just for your clarification, to know the components, how to know the components and phases. For that purpose, I am taking these examples. Phase is called 1, components is called sugar is chemically different, and water dissolved in water. Therefore, component is called 2. Right. Next, kerosene in water. So you cannot. It's a organic. Kerosene is organic. Kerosene or petrol are purely organic. Water is purely inorganic. Polar, non-polar. You cannot mix. You cannot make homogeneous. Therefore, number of phases is equal to 2. And components also 2. Air, suppose it composed of, let us assume it composed of only main components, oxygen and nitrogen. O2, air composed of O2 and N2. But air is a homogeneous, one phase. Phase is called 1, components is called 2. If carbon dioxide also there, 3. Of course, negligible amount is there. Just for your explanation, I neglected that. Right. So both are non-miscible. If you say vigorously, you cannot make homogeneous. You cannot mix. So it's a heterogeneous system consisting of 2 or more than 2 phases. All these are homogeneous. Right? Here heterogeneous. You cannot consisting of 2 phases. Heterogeneous system. And a best example for heterogeneous also. Right? Whose irrespective of closed or open system. Here, just for your clarification, I am taking this example. Right? Like this. So main problem, some two different exceptional cases are there, like ammonium chloride, NH4Cl in a closed system can be possible to obtain dynamic equilibrium. It converts into NH3 plus HCl. It's a gas, it's also gas, but it's liquid. Some exceptional cases, even though their chemical constants are different, components is called 1, not 3, because when you combine both, you will get this one. So if by taking only definition, what is the definition? Components, minimum number of chemical constants required to define, to measure each phase of composition of each phase. But here minimum, this is enough because both are there in one. When you mix these two, when you combine these two, you will get this. A plus B is equal to C. If suppose it is C, A plus B is equal, you will get this one. Both are there. when you come to this salt solution is there, you cannot get the salt solution from H2O, you cannot get NaCl from H2O. Even after combining NaCl, H2O, you cannot get that one formula. They are chemically different. Even though they are chemically different, they are there. Ammonium chloride. By taking this ammonium chloride only, we can define each phase of system. So, how many phases are there? Gas, miscible. Possible phases are 2. So, another exceptional cases. Some examples. Exceptional. 1. Ammonium chloride. 2. Calcium carbonate. So, when they attain dynamic equilibrium, it means these conversions can happen in a closed system. Should be detached with the surrounding. Then only possible to get dynamic equilibrium, right? So, calcium carbonate in a closed system can be decomposed on heating. This decomposes into calcium oxide, is a solid, plus CO2, is a gas. If they are in a closed system, if it is an open system, it escapes out. So, not possible this dynamic equilibrium. You cannot get this equilibrium. In a closed system only, it can be possible to get this dynamic equilibrium. At dynamic equilibrium, rate of forward reaction is equal to rate of backward. So, on heating, it decomposes into calcium oxide and CO2. Here, minimum number of variables, we need to consider 2. Minimum number of variables, 1, no, solid 1, solid 2, solid 1, solid 2, and it is gas. This is gas. Minimum number of phases are called 3. You cannot mix solid. They are chemically different. You cannot mix. You cannot make homogeneous. They cannot be mixed both solid or gas. So, number of phase called 2, but number of components is called, number of phase called 3, number of components is called 2 only, because solid, they are different, chemically different, they are different. By adding a CO2 to this, you will get this one. Or by subtracting CaCO3, A, B, D, suppose. Subtracting A minus B, and then that is calcium carbonate, B is equal to, you will get D. Or B plus D, you will get A, like this. But since solid 1, solid 2 are different, you cannot mix. We need to consider 2 components minimum to define each phase, to describe each phase of heterogeneous system at dynamic. To describe each phase at dynamic equilibrium of heterogeneous system, we need to consider 2 components. These are only 2 exceptional: decomposition of calcium carbonate and ammonium chloride. So, phase diagrams explained by taking 2 formulas. These formulas are called Gibbs formulas. Gibbs phase diagram formulas. Phase rules for one component system, like water phase diagram, formula that we use, F is equal C minus P plus 2. For 2 component systems, 2 component system like silver, lead and iron, carbon, steel, for making of steel, iron, carbon phase diagrams, we use F is equal to C minus P 1. So, why this for 2 component system like lead acid and iron carbon system, this formula is condensed, reduced, F is equal to C minus P plus 1, because So here we need to make alloys, brass or steel. We need to melt in a furnace. High temperature. We need to maintain very high temperature inside. So converting heavy metal into liquid, making heavy metal into molten metal, highly difficult. Therefore, pressure formed, very highly difficult. So whatever vapor formed, very high difficult. So vapor formed negligible. So pressure exerted by the vapor also negligible. You cannot take it into consideration, because converting heavy metal into molten. What is the purpose of converting heavy metal into molten metal? We need to mix to make an alloy. Like brass, we need domestic purpose. Of course, their melting points of alloys are lower than the melting point of the individual, but they are highly resistant to chemicals, highly corrosive resistant. Therefore, for making of alloys, we need to melt at high temperature inside furniture. So, converting heavy metal into molten, highly difficult. Therefore, vapor formed negligible. Pressure exerted by the negligible vapor also less, very less. You don't need to consider. You don't need to take it into consideration. Therefore, that out of pressure, temperature, composition, this pressure variant is neglected. Only we need to consider temperature and composition to define two component phase diagrams, right? Two component phase diagrams helpful for making of alloys while cooling at various temperature exhibit different characteristics, right? So out of one, this formula is reduced, condensed. This second rule is called condensed phase rule. Condensed Gibbs phase rule. Right? This phase rule. For one component, we need to take this to define each phase, to know component, to know the degrees of freedom at various temperatures. We need to consider this formula. F is equal to C minus P plus. In the syllabus, you have only water system. So let us discuss water system. First phase diagram. One component, water system. Here temperature increasing, here pressure variant, pressure represented by P, temperature represented by T, minus 273, 0 degrees centigrade, next 100 degrees centigrade, next 373 degrees centigrade. So at 0 degrees centigrade, vapor formed very less. So pressure exerted at this point also very less, about 4.5 mm. Mercury pressure exerts, vapor formed very less. On boiling to 100 degrees centigrade, so pressure exerted at this temperature is about 1 atmospheric pressure. On boiling at high temperature, water starts boiling, vaporizes, whatever available place is there just over the surface of water, vaporization takes place, and the vapors, they collide with the walls and they collide each other. Once it's saturated, available space just above the water, during process of boiling, water molecules, vaporized water molecules, they collide each other, they collide with the walls. That is known as pressure. So pressure exerted by very high at 100 degrees centigrade. 373, after 373 only one phase exists, that is vapor. So after 373, at 373, let me draw here. So after this 73 only one phase exists. After this So at this temperature, pressure exerted about 218 atmospheric pressure, right? Connect these points, right? So what about ice inside? Already I discussed that example. Even if it is possible 0 degrees, below 10 degrees possible, we maintain it's a closed system. Refrigerator is a closed system. Inside deep freeze box, closed system. Once you open, ice starts melting. As long as it is closed, definitely equilibrium, possibility of equilibrium existence inside, right? So below 10 degrees, usually we observe at home, outside we cannot maintain 10 degrees or 15 degrees. Outside room temperature 25 degrees. Outside house about 30 to 33 degrees centigrade. So only refrigerator is possible, that temperature that we maintain possible in refrigerator. Best example, refrigerator. Inside refrigerator below 10 degrees centigrade. Inside deep freeze box 0 degrees centigrade. -5, -10, we can decrease temperature further, -5, -10 also inside deep freeze box. So we need to take this example, already I mentioned here, while defining the phases and components also. Already we discussed it. You need to write this formula only. So inside deep freeze box, existing possible phases are 3. H2O, 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 all are represented by one formula, H2O, liquid, H2O, vapor, just like white smoke inside deep freeze box, vapor, H2O, ice, the solid form, liquid form, gas form, right? So ice also there, we need to, where is ice curve? Only this curve shows only vaporization and ice formation, that we need to mention that also, right? Put A O C O B, right? This is called 100 degrees, 0 degrees, 10 degrees also water vaporizes, but water boils at 100 degrees centigrade. At 20 degrees also during ocean, at where region to region, country to country, the temperature of the ocean changes. So average Earth surface temperature is about 27 degrees only. Therefore, even at 15 degrees water vaporizes, but amount of extent of vaporization very less when you compare with temperature at 40 degrees centigrade. During daytime, temperature also varies place to place, region to region, country to country. Therefore, even at 10 degrees centigrade, it vaporizes. 20 degrees increase, vaporization increases. At 30 more, like this, right? This is called vaporization. H2O liquid, right? H2O vapor. Below 0 degrees, below 10, ice starts, below 0 degrees centigrade, ice starts solidifying. You will get ice also, H2O ice or solid, right? Both are at a long curve OA at any point, both are at dynamic. This OA curve indicates these two conversions. Already we discussed it while defining each phase. At 100 degrees centigrade, water starts boiling. We have two phases. Even after 20, even after 10, water starts vaporizing, but amount of vapor very less. Even 20 degrees better, 30 degrees more vaporization. So vapor, this OA curve indicates, this OA curve separates both vapor and liquid water, and possible phases are 2, and both are at dynamic equilibrium. Therefore, along OA curve at any point, you take any point, liquid phase and liquid H2O and vapor H2O are at dynamic equilibrium at a given temperature and pressure. This curve is called vaporization curve, OA, vaporization curve. Along OA, it separates both. This vaporization curve separates H2O liquid and H2O gas, vapor. You can write that equation also here. Sorry. So along OA, possible phases are H2O liquid is at dynamic equilibrium with H2O vapor. This way, these two visible to you. Just you need to practice only diagram. Keeping diagram in mind, you can define each phase. You can also calculate degrees of freedom along OA curve, right? So H2O, it separates both this liquid and vapor, right? So along OA curve at any point, along OA at any point, both are at dynamic equilibrium, this and this, right? Dynamic equilibrium at a given temperature and pressure. Temperature variant is there, pressure variant is there. Degrees of freedom, possible phases are, how many are there? 2. Represented by only one formula. Vapor composed of H2 molecules only, liquid is composed of H2 molecules. Component is called 1. Degrees of freedom is equal C minus P plus 2 for one component system, right? Therefore, 1 minus P is equal to 2 plus 2 is equal to minus 1 plus 2 is equal to 1. Degrees of freedom is called univariant. This is called univariant. So by changing either this or this, equilibrium collapses. Equilibrium does not exist, right? So it is called univariant. Next, curve OB, curve OC. Both are at dynamic equilibrium. Ice H2O and liquid. Ice and melts. When you open the defreeze box, it starts melting. As long as it is closed, then only we can maintain dynamic equilibrium, right? So at dynamic equilibrium, possible phases are, this OC curve represents, OC curve is called melting curve, and this separates both ice represented by H2O liquid. This separates two, right? Both are at dynamic equilibrium. Along OC at any point, both are at dynamic equilibrium. You can write like this: along OC curve at any point, these two phases, solid and gas, liquid or dynamic equilibrium, solid, liquid or at dynamic equilibrium. This represents dynamic equilibrium. At dynamic equilibrium, possible phases are, degrees of freedom is equal to number of phases 2 with number of phases 2, components is equal to 1, degrees of freedom is equal to C minus P plus 2 is equal to 1 minus phases 2 plus 2 is equal to plus 1. Univariant.
So along OC curve at any point both are a dynamic, ice and vapor of ice, smoky type, white, no other word in English, vapor of ice, vapor of water. If it is during boiling, it is called vapor of water. During cooling, it is called about 5 degrees, about 0 degree, minus 5, minus 10, whatever inside fog type is formed, it is called vapor of ice. So along OC curve at any point both are at dynamic equilibrium, ice and liquid, and this OC curve separates ice and liquid water. This OC curve slightly inclined towards the pressure curve. So it means on increasing pressure, keeping temperature constant, on increasing pressure, its melting point of ice decreases. So instead of 0 degree centigrade, ice starts melting 0 degree centigrade after 0, plus 1, plus 2, plus 3. So on increasing pressure, this curve, OC curve, slightly inclined towards the pressure curve, shows keeping temperature constant, no change in temperature. Change the pressure, increase the pressure. So its melting point of ice decreases. Right? It may melt even at minus 5 degrees centigrade. Like that. Degrees of freedom is equal to 1. Hence it is univariant. Next, OB curve. So here vapor of water, vapor of ice, vapor of, here also vapor. Both are at dynamic equilibrium. Both are at dynamic equilibrium, ice and vapor of ice. OB curve. When ice vaporizes, that it is called conversion of solid into vapor is called sublimation. Therefore, it is called sublimation curve. OB curve, also called sublimation curve. Sublimation curve. Right? Along this curve, vapor of ice and ice, H2O, two possible phases. H2O, ice, vapor, right? Solid, gas. Two phases, possible phases along OB curve, two phases. Phases is called 2. Component is called 1. Degrees of freedom is equal to C minus P plus 2 is equal to, component is called 1 minus 2 phases, P is equal to 2 plus 2 is equal to univariant. So along OB curve at any point both are at dynamic equilibrium, either changing pressure or temperature, equilibrium changes, right? Therefore it is univariant. Next, areas of phase diagram. How many areas are there? AOC, only one liquid phase exists. AOB, only vapor of ice, vapor of water. Both are miscible. Since they are gases, gas miscible. Even they are different chemical, they are different, but can be mixed together. Air composed of two, water and, but it is only dependent by only one formula, H2O. Composed of only one chemical constituent, that is H2O, right? So both are mixed, identical, homogeneous, even chemically also same, homogeneous. Here O2 and O are chemically different, but homogeneous. Phase is called 1. Here phase is called gas, since both are gases, can be mixed, represented by only one formula, therefore identical homogeneous phase, vapor, ice. So AOB area, only one phase exists, that is gas phase. BOC, what is visible to you in the graphical representation in this diagram? Only solid, that is ice phase. So AOC, areas are AOC, BOC, AOB. AOC, AOB, AOC. Only phases, only one phase exists. Phase is called 1. Degrees of freedom is equal to C minus P plus 2 is equal to component is called 1. Component is called 1 is equal to 1 minus 1 plus 2 is equal to, depends on both temperature and pressure variant. So it's bivariant. Depends on both. So we can for all three areas also same. This is only one phase, liquid phase. This is only one phase, AOB, vapor phase, vapor of ice and vapor of water. This is phase only solid, ice phase, ice, vapor, liquid. So for all areas, degrees of freedom also 2, bivariant. Both are fixed. Temperature either changing either one. This state phase also changes, right? Next, at total cause, the point, triple point. It's a very important triple point. AO, OC, BO meet each other. This point is called triple point. At triple point, possible phases are liquid phase, ice phase, vapor phase. Vapor of ice, vapor of liquid. Since both are gases, can be made together, so homogeneous. So vapor. Possible phases at 0, visible to you in the diagram. Vapor, solid, liquid. At triple point, the point at which OB and OC meet each other, called triple point. At triple point, possible phases are 3. This is the equation. You can write this equation. At triple point, H2O, liquid, ice, vapor. Possible phases are 3. 1, 2, 3. 3 phases. This is liquid. This is solid. This is gas. Possible phases are 3. Represented by formula 1. Degrees of freedom, F is equal to C minus P plus 2 is equal to 1 minus P is equal to 3 plus 2. 0, non-variant. So all are fixed. Changing any one, all are fixed. All are fixed. Changing any one, equilibrium collapses. Right? Best example, just to open the defreeze box. Outside temperature 27 degrees centigrade. Inside temperature, inside about 0 degrees centigrade. So ice starts melting. When you open the door, vapor, smoke type, fog type. It is called vapor of ice. It will escape out. Ice will start melting.
equilibrium collapses. Equilibrium will collapse. So equilibrium does not exist. So all variants are fixed. Changing either one, any one, equilibrium collapses. Therefore, non-variant, all are fixed at O, at point O. So it's a non-variant. With this, I conclude. Iron carbon system we'll discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.